Hello there. Hello. Today we are in, I suppose this must be the third video of the more complex machine learning workflows that are part of this Avis tutorial series. Today what we're going to be doing is looking at how we can take a video and use a speech recognition algorithm to extract the spoken words within the video and then display the results as an interactive video manifest within Arvest. Today we'll be able to head over to the API and ML and Machine Learning tab on the Arvest website and head over once again to the ML Notebooks repo, and we shall go down to the ML workflow tutorials. And here we are. So today we are going to be looking at this distant listening notebook over here. So as always, you have either an online or an offline version of this Python notebook. So if you hit the Colab version, then you can get it all going from there and it should work fine. And you also have a local version which you can look at here. So again, I will be using the local version just because it's a bit faster and a bit easier for me because I already have it cloned and all that stuff. So, indeed, I have it cloned on my machine and ready to go in VS Code. If you want some help with that, then you can have a look at the first episode in this tutorial, in this API tutorial series, which goes over that kind of setup. I'm going to head over to local, to workflows, and to distant listening. And I'm going to open up the first file, which is this audio speech recognition folder. So what are we going to be doing exactly? So we are going to be taking a video that we have stored on Avest. Then we're going to extract the words that are spoken using a speech recognition model provided by Vosk. So what is Vosk? Vosk is I believe an open source speech recognition toolkit. In any case, you can freely use their models without having to pay with them or anything like that, and they all work pretty well. So I highly recommend using Vosk. And then once that is done, we shall be taking the results and building an interactive IIIF manifest, which can be viewed directly in Arvest. So, as always, we've got this first horrific setup cell with a load of things which aren't very pretty to see, but just to sort of quickly go over things, we are having a clean install of all the packages that we will be needing, and then I'm importing them. So we've got the Arvest API package, you've got the Arvest tools utilities and some other utility packages. I'm importing the distant viewing toolkit here, which I won't need for this, so I don't know why I did that. The IIIF Prezi 3 package, which is going to allow us to create IIIF manifests, Vosk, so Vosk's Python package, and a few other things like Librosa and Wave, which allows us to interact with audio files. Same thing for SciPy, all that's for some of the audio treatment that we're going to be doing. And I've created a temporary folder here as well. So that is done, that is ready, and we will also need to be downloading a model. So this is all going to be working locally on our machine, which is an advantage to Vosk. Basically, if we go to Vosk's website using this link here, you'll see that they've got a whole host of different models for different languages, basically. There may be a multilingual model, I'm not sure. I haven't... no, maybe not. But so these different models you will choose basically according to your needs. You see that there's the size with them. For example, this 1.8 gig model is something that you can use when speed isn't an issue, or memory isn't an issue, but this 40 megabyte model is something you'd use maybe, I don't know, if you're, well, for example, using wanting to make something for Android or something like that, and obviously other models for other languages will work better on other languages. So how this works in the script, if I kind of put that like that and put that like that, all all you will need to do is just change the name of this variable here to the model that you wish to download, and then it should all work. If you're running this locally, it will actually it will create this models folder, and it will unpack everything into the folder. So I'll press play. It won't actually download it for me because I've already got it downloaded, this basic English small US model. But that's what it's doing. It's basically downloading the zip file, which is got from this link, and then it's unzipping it, and it's loading the model using into an instance of Vosk's model class. So even if you've already downloaded the model, you will need to run this cell just so that the model gets loaded into the model variable. So our model is ready to go. That's all great. Now we need a video to analyze. So what we're going to do is we're going to take a video that we'll have stored on Arvest. So first thing I'll need to do is connect up to Arvest. So for this, I'm using the Arvest API package and creating an instance of the Arvest class. So we'll have gone over this in previous tutorials, but I'm going to go ahead and click play there, and I have connected with my my account. So if I go to the Arvest website and connect, so this is my account here. At the moment, I'm actually going to upload a video that I've prepared beforehand for this. So if I need to find it on my computer, it's going to be in this test media folder. So get rid of those tabs which you're not interested in. So I created this little video earlier. Hello there. My name is Jacob, and this is a test video to test speech recognition. So yeah, I apologize for the for the testiness of the video, but yeah, I just wanted something where I was speaking very clearly just to make sure that this model will work, just for demonstration purposes. So I have my video here. I need to get it into Arvest. So as we know, the best thing for that is to go over to our instance of PeerTube, and I'm going to publish it. So I'm going to select my file here. Just keep the name as is. Hello there. There we are. So my name is Jim. It is now on PeerTube. I'm going to take the link from here rather to be sure that everything will work, and I'm going to add a link to this media. Up. There we go, and I'm going to call it speech recognition test. There we go. So that is uploaded to Arvest. And now, how do I get access this in my script? Well, basically, I'm going to use the Arvest API's get medias function to get a list of all my medias, and then I'm going to check if each media has a metadata field, the identifier field, that is equal to this value, for example. So what I'm going to do is I'm actually going to copy that, come back into Arvest, and I'm going to edit the metadata. I'm going to find its identifier, and I'm going to paste that in. Here we go, and now it should be able to, my script should be able to find this media file. Just notice that it's putting it into a list, the idea being that we could make this script so that it processes more than one video at once, but Yeah, we're just processing one. So I'm hit play on that, and it found my one media file, and it is indeed the speech recognition test. And now I'm going to need to download it because Vosk is working locally, so we need to download the media file onto our computer. So this is just a helper function that I provide called download, which will should work with YouTube or PeerTube or direct link video files. So I'm going to do that. Now, so I've downloaded it into this temporary folder. So if I reveal this in my Finder, I can have a look at it here. Hello there. So I've successfully managed to download it again. So you're probably wondering, well, why did he bother downloading it if it already exists within his computer? It's just to kind of demonstrate how this would work if you just had a video that that you just had hosted on Arvest. So yeah, obviously I could have just used the video that I already have on my computer, but you know, it's just for demonstration purposes. And then what I'm going to do is I'm actually going to convert this into a WAV file, because our algorithm, our Vosk algorithm, doesn't take into account the video content. It just takes into account the audio. So I'm going to turn this into an audio file. Now to do that, I'm going to be using FFmpeg. So this is a command line tool. It's not strictly Python. And you'll need to make sure that is installed in your system. I believe I should have made it so that FFmpeg installs itself. I haven't yet, so that is something that I will need to add to this package, but you can install it directly from the notebook, so I will be adding that functionality soon. But so if you get errors here, it's probably because FFmpeg is not installed, so you'll need to do that. And so basically I'm converting it to a WAV, but I'm also changing the audio rate, because Vosk is a model, machine learning model. You need to give it content of a certain shape, of a certain number of dimensions, and Vosk needs you to give it content that is at audio rate of 16,000 samples per second. That's just the way it is. And one single channel as well. So if it's in stereo, it needs to be merged down into one channel. So I'm going to do that, and you'll see that we have created this file here. So if I quickly listen. Hello there. My name is Jacob. So it's still the same sound. You'll notice that the sound quality has dipped. That's because we have downsampled. That's just the way Vosk works. We can't get around that because Vosk needs us to have this audio rate. So before we actually perform our analysis, we can do a bit of audio pre-processing to try and boost the success rate of the analysis. So basically what we're going to do is we're going to use, I mean, I won't go into details of this, but I'm going to use a number of tools to reduce the noise and perform normalization as well. And we also need to rescale the data to 16-bit depth because Vosk also expects that for the shape of the data that it will receive. So I'm going to quickly run that, and it overwrites the audio file that was created before, so that that will have updated there. And now that we've done that pre-processing, we can actually perform our analysis. Oh, and now I'm seeing that, yeah, so our analysis is working here. What we're going to do is we're going to create an instance of the calendar recognizer class from Vosk, which takes as its first argument the instance of the model class that we loaded at the top of the script. And I'm seeing here also that it takes a audio rate as its second argument. So I'm wondering if it's me that that set that audio rate to be 16,000, which I find Hard to believe because 16,000 is a very low audio rate, but maybe it was me, maybe not. I can't quite remember. But anyway, that's what that 16,000 corresponds to. And then, so this is just so that we can retrieve the words from our analysis. Here we load our audio data as, I believe, a NumPy array. And then we run that data on the accept waveform, which is a function of the Vosk's calendar recognizer. And that will give us some results. So if I run this, it shouldn't take too long. Hey, so we have our results. We found 18 words. Hello there, my name is Jay Him. And this is a test video to test and speech recognition. So it's not perfect. And indeed, in fact, it's not very good at all, but I mean, we're mainly there, but that's pretty high error rate for such a small video. It's probably mainly because I downloaded the 40 megabyte model for this example. If it was with the bigger model, then I expect it probably would have performed a lot better, but this computes a lot quicker and is a lot takes up a lot less space on my hard drive, so that's why I've opted for this smaller model. Anyway, it's enough for demonstration purposes, and we can move on from there. So yeah, our results have been put into this result algorithm variable, and that is what we're going to be using next to create our interactive visualization of these results. So to do this, what we're going to do is we're going to create a manifest which will have at its base this video source. So to do that, we'll be using the Arvest Tools media to manifest function, which directly takes a video item which we found way up at the top here. Yeah, video item. So we'll be using that and creating a manifest from that. So we shall do that there. And then we shall be adding annotations for it for each word that was found in the analysis. So you can see I'm taking my result variable, which I found up here, and I'm going through each word. And so I'm printing my progress, but I'm mainly using Arvest Tools add textual annotation function in order to add a textual annotation to my manifest. So this is the manifest. It takes its first argument. The textual content. So this is HTML. So you can make it look quite nice. I'm putting the word in bold, and then I'm also putting the confidence of the word, which is an interesting factor. We'll see if the confidence was pretty low for the J, him instead of Jacob earlier. And also the start and the end of the times of the word. So this is all stuff that we got in our results from the Vosk analysis. And we'll also be setting the time to the start and the end. So we shall do that now. Yep, that is done. And then we're uploading it to Arvest. So this is stuff that we'll have seen in previous tutorials, but yeah, we're saving our manifest to disk, we're uploading it to Arvest, we're changing some basic metadata and stuff like that, and then we're printing out the preview URL, which will allow us to open the results straight from our script. So there we are. I shall open it up. So here I am. I'm beginning to regret having used myself for this example, but there you are. So we see that we've got our annotations here. Hello. So here we've got confidence of 1. Hello there. My name is J, him. And you see that here the confidence dips significantly. And this is a test video to test, and which I know is not correct either, is at 0.5 confidence speech recognition. So yeah, that seems to all compute. And if I press play here, hello there, you can see that the annotations are
a test video to test
are going by and getting selected as we go through the video, and if I want, I can use them to scrub through my video.
And this
so I can jump to the place where they are in the video.
Test video to test.
Oh yeah, so it's and it got confused with So yeah, these are the joys of machine learning. And on that lovely image, I shall close that. So just to demonstrate also, so we opened that using this link that we can print out using the get preview URL. But we can also go ahead to our workspace and find it here. So yeah, that's pretty much it. We just need to clean up now, so we can remove all of our temporary stuff from this temporary file. And we can also remove the stuff that I've just created from Arvest. So we can remove the manifests by getting all the manifests, seeing if it's something to do, if it has a certain metadata, and then remove it. So I might as well do that. And now it should be removed from my manifest list, which it is. So I hope that was useful. If you have any questions, please don't hesitate to ask them in the comments below. And you should be able to find links to all of the things that you may need in the comments as well. Thank you very much for watching, and I shall see you in the next one.